Hello everyone, this is Pranay. Today I'll be talking about our Unix Lab Experiment number 9, which is related to pipes. Pipes are used for inter-process communication. It is based on the principle of first in, first out. Okay, and this is used for inter-process communication basically. Okay, there can be two types of pipes. Sorry, there could be two types of pipes, that is unnamed and named. Unnamed is basically you don't, well, it's like, just take an example of a father and a son. The father knows his son and does not call by, and the son does not call his father by his name. So it's like an unnamed pipe. Actually, they don't know each other. It's like, okay, these processors know each other, but in a name file, the two processors do not know each other, so they call each other by using names. Okay, for a unnamed pipe, there is one example, and today we will be seeing an example for that. A program is there for that, and for name pipe there are two programs, read and write. Okay, so what happens is, first writing operation will be done in the pipe, and reading option, then there will be whatever data is written into the buffer will be read out through the other side of the pipe. It works like that. So you put some values into one side of the pipe and we take out that values from the other side of the pipe. This is the basic logic of pipes, and it is used for inter-process communication. So let's see first an example for unnamed pipes. So let me just show you that. So it's a C program, Q1.C. So it's a small program. These are the header files required for this. Okay, so what happened, these are the basic variables that I've used. Okay, just there is some problem once again. Okay, sorry for that small glitch. So in the pipes experiment, as pipes concept, this is the first example for an unnamed pipe. So what happens is, to create a pipe, and to create an unnamed pipe, you use the pipe system call, in which you'll be passing a file descriptor. There will be two different files to descriptor for writing and reading. That it will return some integer value id. If this id is equal to 0, then the pipe is created, else it is not created. Now what I'll do, I'll take a string, and I'll get a string, I'll write that string. As you have seen in the experiment number 7 how write function works. So I'll pass the file descriptor, the string buffer, as we have declared it, it's a character string buffer array. Okay, I passed it here, and the length of that string. Okay, now if the child PID is equal to fork, is equal to 0, if it's the child process, then I'll get the child process ID and the parent process ID, and I'll read whatever the content is there in that. Okay, and number of bytes is the return value for the read function. And if that what do you call, here what it does is, all the vowels will be changed to uppercase. Okay, so if I write hello, or whatever vowels are there, it will be changed to uppercase. Okay, and that string will be printed. Okay, so this is our unnamed pipes example. So there is one writing operation, so it is a first in, and reading operation, whatever is out comes out. Okay, so okay, let us see that. So cc q1.c. now let's so pipe is created, enter a string. So let's say I'm saying HELLO. Okay, so all the vowels will be turned to uppercase. So parent process ID is 11920, child process ID is 11956. Okay, and the received string is HELLO. So E and O are capitalized because those were the vowels. So this was our example of an unnamed pipe, in which we did not give any name to that pipe. Okay, let us see an example for a named pipe. Okay, so first we need to write the program for the write function. So q2.c. in this, to create a pipe, what we'll do is, it's just simple. Make node will be used. name for that pipe will be given, for example my pipe, with all the required read-write operations. Okay, this is how you create a pipe. If id equal to 0, the pipe is created, else it is not created. You enter the string that will be put in a, you enter the string that will be put into a buffer, and you open that file, open that pipe, okay, with all the reader operations, and write with the file descriptor, buffer, and string length, and close the file, and what the writing operation will be done. Okay, now let's see the reading operation. Okay, so read is also very simple. So in the read, you open the pipe, that is my pipe, with all the read write permissions. You get the file descriptor. Now you'll read, pass the file descriptor, buffer, and size of the buffer, get the bytes, and printf whatever is there in the pipe. Okay, buffer in pipes, whatever is there in the pipe. And that is how you'll get pipe. So what happens is, you writing, what you're doing is, it's like one program communicated to the other program. In one program you wrote the, what you call, you wrote some data. In the other program you reading that data, usage of a pipe in the middle. Okay, and that's how inter-process communication took place. Let us see how it works out. Okay, so let me just compile. So let me just write something. So cc, okay, I'm writing pipe is created. So I'm writing, just write, I write my name Pranay, enter the string. Now it is written into the pipe. Okay, now to read that pipe, I'll just compile the third program, that is the read program. I'll just run it and see the buffer in the pipe was Pranay. So using these three programs, we learned the concept of unnamed pipes, named pipes, and the main concept pipes for inter-process communication. Hope you have enjoyed this video, learned something from it. Thank you for watching. Have a nice day. Bye bye.